we talk about electromagnetic optics. Wave optics fails to explain the polarization phenomenon of the ray. Here in wave optics, wave is considered as a scalar phenomenon. The reflection and reflection of the light depends upon the polarization of the light, but this light must be treated as a vector. Wave optics fails to explain this. The electromagnetic optics is a vector theory comprises of electric field and magnetic field, which vary in time and space, and both are perpendicular to each other and also perpendicular to the propagation of the wave. The electromagnetic field is described by two related vector fields that are electric field and magnetic field. The change in electric field generates a change in magnetic field. That time varying electric field generates a time varying magnetic field. And the same way, time varying magnetic field generates an electric field. These are the few Maxwell equations. Four Maxwell equations: Gauss law for magnetism, which says that monopoles do not exist, Faraday's law and Ampere's law. From the Maxwell's equation, we can derive the wave equation of the wave, electromagnetic wave. Here, mu is the permeability, epsilon is the permittivity depending upon the medium. Electromagnetic waves in a dielectric medium. Let us consider a simple case of linear, non-dispersive, homogeneous, isotropic dielectric medium, where the polarization is depending on the electric field. You see that the polarization depends upon the permittivity, electric field, and electrical susceptibility. From the electric field, we can understand the kind of polarization that a electromagnetic wave is going through. These are the few basic formulas. The ratio of the speed of light in a free space to that of a medium is a refractive index. For a non-magnetic material where permeability is considered as free space permeability, we can say that refractive index is square of the dielectric constant. The basic form of waves which are present in electromagnetics are plane wave, where electric field and magnetic field are perpendicular to each other. Spherical wave, where it depends upon the distance at which it is traveling. And yes, the polarization phenomenon, it is the property of radiative electromagnetic waves describing the time varying direction and relative magnitude of electric field vector. The trace and magnitude of the electric field vector are observed in the direction of light propagation. The process of transforming an unpolarized light into a polarized light by sending it through a medium or a device that is called polarizers. Typically, there are three types of polarization, which is linear, circular, and elliptical. In linear polarization, it's nothing but the electric field is limited to a single plane. Polarization where y component is 0 and y-axis linear polarization where x is 0. This is in the same plane where both are equal and the phases are also equal. Circular polarization is a special state of elliptical polarization. Two components, magnitudes of x and y components are equal, but there is a phase difference of 90 degrees between them. They cause a polarization in like if we see the cross section, it will be in a circle. It depending upon the phase difference between EX and EY, left and right circular polarizations are classified. Anything other than the linear and circular can be elliptical polarization. Elliptical polarization has different magnitudes and phases between the X and Y components of the electric field. The polarization device maintains the plane wave nature of the wave but changes the polarization of the wave. Let us consider two complex envelopes of two electric field components incidented and outputs are taken. Output can be through like transmitted or reflected. The change of the input can be considered through Jones matrix or which is a transfer matrix relating the output and input. The Jones matrix it depends, it changes from one device to another device. Let's say for polarized light to be linearly polarized, this is the transfer function of the Jones matrix. In this, the system is a linear polarizer with its transmission axis pointing in the x direction. Wave retarders alter the polarization of the wave traveling through it. Here, there are two kinds of wave retarders, quarter wave retarder, half wave retarder. We can see a linear polarizer is converted into a left circular polarizer. For a quarter wave, right circular polarizer is converted to a linear polarizer in a quarter wave. A linear polarizer is again converted to a linear polarizer, but there is a change in the phase polarization, which is a 180 degrees change between the previous one. Here, the right circular polarization is converted to left circular polarization in half wave retarder using half wave retarder. Polarization rotators, while a wave retarder can transform a wave with one form to another of polarization into another, polarization rotator always maintains the linear polarization of the wave. The polarization is same, but rotates the plane of polarization by a particular angle. Let's say the wave is having having a particular angle of theta 1. After polarization to theta, it attains an angle of theta 2, which is the sum of theta 1 incident angle and the rotator angle. Applications of polarization, they have been used in imaging applications by placing a linear polarizer over a light source, the lens or both. It is possible to eliminate glare and hot spots from reflective objects. Polaroid filters are used in plastic industries to perform stress analysis. Three-dimensional movies are produced and shown with the help of polarization. Polarization is used for differentiating between transverse and longitudinal waves. In chemistry, the organic compounds are tested. The chirality of the organic compounds are tested using polarization technique. In this section, we will examine the reflection and diffraction of monochromatic plane wave of arbitrary polarization incident at the planar boundary between two dielectric medium. The mediums are assumed to be linear, homogeneous, isotropic with impedances N1 and N2, and eta 1 and eta 2, reflective indices N1 and N2. Shown in ray optics, the wave fronts of these waves are matched. The angles of reflection and incidence are equal. The angles of reflection and incidence are equal. Theta 1 is equal to theta 3. Angle of reflection and incidence satisfies Snell's law. These are the few equations of the reflection and reflection under transverse electric mode, that is, transverse electric polarization, that is X polarization mode, that is perpendicular, orthogonal to the plane of incidence, and Y polarization is the transverse magnetic, which is parallel to the plane of incidence. These are the transmission matrix and the reflection matrix. This is the impedance of the medium, depends upon the electric field and magnetic field. It is the impedance of the medium is the ratio of electric and magnetic fields. Applying the boundary conditions, hitting them, we can see that the reflection, the TE polarization, deflection, and transmission are seen here. We can derive these equations. Brewster's angle, also known as polarization angle, is the angle of incidence at which the light with a particular polarization is transmitted perfectly through a transparent dielectric surface with no polarization. It can be seen at external reflection where N1 incident medium refractive index is less than transmitted medium refractive index. Application of Brewster's law is polarized sunglasses, where we use the glasses to reduce the glare that is that is reflected from the sun. In polarization maintaining fibers is a special type of single mode fibers. In these fibers, in a fiber with circular cross section, each mode has two independent states of polarization with the same propagating constant. Thus, the fundamental mode, LP01 mode, in a single mode weakly guided fiber may be polarized in X or Y direction. The two orthogonal polarizations have same propagation constant and same group velocity. In principle, there should be no exchange between the two orthogonal polarization components. If the power of the light source is delivered exclusively into one polarization, power should remain in that polarization. In practice, however, slight random imperfections and uncontrollable strains in the fiber result in random power transfer between two polarizations. Thus, linear polarized light at the fiber output is generally transformed into elliptically polarized light at the fiber output. Um, to maintain this kind of to reduce the energy shift between the two polarizations, we use the polarization maintaining fibers.